Alright, now let's talk about the Lewis structures and how to draw these, and then we're going to determine the shape and the polarity for the molecule. Okay, number 19, BH3. The first thing that you have to be able to tell is what goes in the center. And in this case, the central atom will be the boron, okay, B. And so therefore, the H's are going to be connected to the B like so. Okay, next thing that you have to do is figure out how many valence electrons there are total. Okay, first of all, there is only one boron, okay, in this molecule, and boron is contributing 3 valence electrons. So 1 times 3 is equal to 3, okay, just from the boron itself. Now, from hydrogen, there are 3 hydrogen atoms in this molecule, okay, and each hydrogen atom is contributing 1 valence electron. So 3 times 1 is 3, meaning that there are 3 valence electrons being contributed from the hydrogen, okay. 3 plus 3 gives you 6. That means that this is the total number of valence electrons, okay. Now, what I need to figure out is how many are used up in the bonds already, okay? Now you should remember that each of these bonds is 2 electrons. So this is 2, 2, and that's 2, okay? That adds up to 6. So that means I have used up 6 in the bonds, okay? Used in bonds. Alright, 6 minus 6 is 0. I have no more electrons to give to either boron or hydrogen, okay? So that's the final structure. Now you should also remember that boron only needs the 6 electrons to be stable, okay? It's satisfied with its 6, so you don't really need to mess with it anymore. Okay, now what shape is this going to be? This is going to be one of the trigonal ones, okay? And you know it's going to be trigonal because it has 3 arms. Now your only problem is it going to be trigonal planar or is it going to be trigonal pyramid, okay? And you know the difference, or you should know the difference between these two is just if there is an electron pair on the central atom or not, okay? In this case, we don't have an electron pair on this central atom. Therefore, this is a trigonal planar. It's going to be a flat molecule. Okay? Now, is this polar or nonpolar? If you draw this in 3D, meaning that I have the boron in the center, got our 3 H's, okay? Basically, it's going to look like that. If you look at it, all the outside is completely the same, okay? And since the outside is completely the same, it is an even molecule, meaning it is non-polar. Okay? Remember that if it's even, it's going to be non-polar. If it's uneven, then it's polar. Okay, number 20, HOCl. Again, first thing you need to figure out is what goes in the center. Well, the H can never be in the center, and Cl is a halogen, so it's never going to be in the center either. Okay, so O is going to be our central atom. Now, that means that H and Cl must be connected to the O. Now let's figure out our number of electrons, or valence electrons, okay? So H, I got 1 H. H has 1 valence electron, so there's only 1 from this. O, I have 1 O. O contributes 6 valence electrons each. 1 times 6 is equal to 6. Okay, Cl, I have 1 Cl. There are 7 valence electrons from a Cl. So 1 times 7 is equal to 7. Alright, 1 plus 6 plus 7 gives me 14. Alright, so again, this is the total. Next, I have 2 electrons used here and 2 electrons used here, okay? And so that means I have used up 4 in the bonds, okay? So I'm going to subtract 4 for the ones that are used in the bonds. 14 minus 4 is 10. Alright, that means I need to put 10 electrons into this molecule. Okay? Ignore the H. H is already done. Once it's bonded, it's finished. Okay? We are going to start with the Cl because we always start on the outside atoms first. Okay? So, the Cl can still take 6 more. So, 2, 4, 6. Alright. Now where do we put the rest? In the middle. 8, 10. That's it. I've used up the 10. Got no more left. Okay? Now let's check to make sure that all of these are fulfilled. Okay? Meaning that they have their 8. Or in the case of H, it needs 2. H has its 2 from the bond, so it is fine. O has 2, 4, 6, 8. So O is okay. And Cl has 2, 4, 6, 8. So Cl is also fine. So this is finished. Alright, now for the shape. What you need to realize is this central atom and the electrons that are on it has everything to do with the shape. Okay? What's going to happen here is these 2 electrons will push away the bonds. So what happens is instead of a straight line, you get a molecule that looks more like this. Okay? With the electron dots looking like that. Okay? And this shape is bent. So notice that since the central atom has those extra electrons, this shape becomes bent instead of linear. Okay? Now is it polar or non-polar? If you look on the outside, okay, this entire outside basically, all of them are different. So that means this is going to be uneven or polar. Alright, number 21, HCN. First of all, decide what goes in the center. H is never going to be in the center, so it's going to be between C or N. Now to decide which one goes in the middle, it basically is whichever one is farther away from fluorine. Okay? And carbon is farther away from fluorine on the periodic table than nitrogen. So C is the central atom. H is going to be on one side. N is going to be on the other side. Alright, now let's figure out how many valence electrons we have. H, I have 1 H. H contributes 1 valence electron, so 1 times 1 is 1. Carbon, I have 1 carbon. Carbon contributes 4 valence electrons, so 1 times 4 equals 4. And finally nitrogen, I have 1 nitrogen. Nitrogen contributes 5 valence electrons. 1 times 5 equals 5. Okay, 1 plus 4 plus 5 gives you 10. Now, again, we have to figure out how many of these electrons I have used already in the bonds. Okay, and it looks like I have 2 and 2 right here. That means I have used up 4. So 10 minus 4 is equal to 6. Okay. Alright, so I have 6 electrons left. Now these 6 electrons have to go on the outside. Okay? The H can't take any more, so must go on the nitrogen. So here we go. 2, 4, 6. Alright, I've used up all 6. No more left. Alright, let's check if everybody is satisfied. Okay? H is satisfied with its 2. Carbon, 2, 4. Alright, so carbon is not satisfied. Carbon needs 4 more electrons to get its 8. Okay, so what we are going to have to do is make nitrogen share 4 more electrons with the carbon. Okay, so we are going to end up with a triple bond. H and C still with a single bond. And N is going to get a triple bond between it and C, okay? And it still has those 2 dots on the outside. So there it is. Alright, so what does the shape look like now? Notice that the central atom doesn't have any valence electrons or any electron pairs on it, okay? So since it has no electron pair on it, it's going to be a linear molecule. Okay, notice the difference between the HCN and the HOCl is really just that HOCl has these extra electrons, and therefore it's bent. Whereas in HCN, there's no extra electron on the central atom, therefore it is linear. Okay? Now polar or nonpolar, H and N are very, very different. Okay? We're looking on the outside again. So that means this is an uneven molecule, so it'll be polar. Alright, number 22, NH3. In this case, N is going to be in the center, and the reason is because H is never in the center. Okay? Alright, so that means the 3 H's will be distributed around the N, bonded like this. Okay, N, I have 1, and N contributes 5 valence electrons, so 1 times 5 is 5. Alright, for the H's, I have 3 of them, and they each contribute 1 valence electron, so 3 times 1 is 3. 5 plus 3 gives you 8. That's the total. Okay, now how many have I used up in the bonds? 2, 4, 6. Okay, so I have used up 6 in the bonds, which means that I have 2 valence electrons left. They cannot go on the H's, so they must go on the N. Alright, so that is the structure finished. Now, I know that there's no space for the shape or the polarity, but the shape for this one is going to be a trigonal. Now, is it going to be trigonal planar or is it going to be trigonal pyramidal? What you have to look at is, again, that central atom. It has an extra electron pair on the central atom, which means this is going to become a trigonal pyramid, okay, instead of a trigonal planar. A trigonal pyramid is basically, you got the N right here on the top as the point of the pyramid, okay, and then you have the H's basically hanging off like a tripod, okay, and it's going to form this triangular base at the bottom of this molecule. Okay, now if you look at this shape and you have to decide on the polarity of this molecule, basically what happens is you get N right here on the top, and right here on the bottom is all the H's, so it's very uneven. So this is going to be a polar molecule. Okay? Alright, moving on to the next page. Number 23 with SO4 minus 2. Alright, SO4 minus 2 means that S is going to be in the center. Okay, and we have the 4 O's distributed all around, like so. Okay, now let's figure out the numbers. I have 1 S. Each S contributes 6 valence electrons. 1 times 6 is 6. And I have 4 O's. Each O contributes 6 valence electrons. 4 times 6 is 24. Okay, add them up. 24 plus 6 is going to give me 30. Alright, so 30 is the total. Now how many have I used up in the bonds? 2, 2, 2, 2. That makes 8. So I'm going to subtract the 8 that was used in the bonds. Okay, 30 minus 8 gives me 22. Alright, for these 22, they need to go first on the outside. But before we get started anywhere, we have to notice that we have a minus 2 charge right here. Okay, now minus 2 just means that it has gained 2 electrons. So this is from the minus 2 charge. Okay, I have to add 2 more electrons. So 22 plus 2 is actually 24. So I'm going to put the 24 all on the O's. Alright, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Alright, I've used up all 24. Got no more electrons left. Okay, and let's make sure that all of the atoms are satisfied, and it looks like they are. So since this is an ion, I'm going to put it in a bracket and give it a -2 charge, but otherwise that's done. Okay, now the shape, since it has 4 arms, this is very easy. 4 arms means tetrahedral. Okay, and all of it, all the outside are the same, so that means it's a pretty even molecule. It's nonpolar. Alright, so that's it. Number 24, NH4 plus 1. N's going to be in the center with the 4 H's hanging off of it. Okay, let's calculate how many valence electrons I'm going to have. I have 1 N. N contributes 5 valence electrons. 1 times 5 equals 5. I have 4 H's, and H gives 1 valence electron, so 4 times 1 equals 4. Okay, and then there's one more thing. The +1 charge tells me to subtract 1. Okay, so I'm going to add 5 plus 4 and then subtract 1, which gives me 8. Okay, again, this is coming from the +1 charge. Okay, so the 8 is the total. Now let's figure out how many I've used up in the bonds. 2, 4, 6, 8. Okay, so I've used up all of them. This was used in the bonds. Okay, so that's pretty much it. All we need to do is put this in a bracket and put a +1 charge on the outside. Okay, the shape, it has 4 arms, tetrahedral. All of the outside looks the same, therefore it is nonpolar. Alright, number 25, CCl2O. Out of all of these, C is the one that is farthest away from fluorine, okay, which means that it's going to be in the center. C is in the center. We have 2 Cl's. So I'm going to have a Cl hanging off here and a Cl hanging off here, and I also have an O. Okay, so that's the basic shape. Now, let's calculate how many there will be. C, there's 1 of them, and C contributes 4 valence electrons, so 1 times 4 equals 4. Cl, there are 2 Cl's, and each Cl contributes 7 valence electrons. 2 times 7 is 14. And O, there's 1 O. Each contributes 6. 1 times 6 equals 6. Alright, now let's add these up. 4 plus 14 plus 6 is going to give us 24. Alright, how many have I used up in the bonds? 2, 4, 6. So I'm going to have to subtract 6. 24 minus 6 is 18. Alright, now where do I put these 18 electrons? Okay, we are going to start on the outside, and let's start with the Cl first, and the reason is because Cl is closer to fluorine. Okay, so here we go. 2, 4, 6, 8, 10, 12, 14, 16, 18. Alright, I've used up all 18. There are no more to give. Okay, now let's check if everybody is satisfied. Cl is satisfied, it has 8. Okay, C is not satisfied, it has only 6, so it needs 1 more. Now I need to force one of these guys from the outside to share, and it's going to come from the O, and the reason is because O has 6 valence electrons, which means it can form 2 bonds. Okay, whereas Cl has 7 valence electrons and can only form one bond. So here we go. Notice that the CLs are still the same, but O is now double bonded. There we go. Alright, so that's it. Now, since it has 3 arms sticking from the central atom, this is going to be a trigonal. Okay, now you need to figure out if this is going to be trigonal planar or trigonal pyramidal. Again, we look at the central atom. No extra electrons on it, which means it is trigonal planar. Okay, polar or nonpolar? Well, we got 2 on the outside that are the same, but there's 1 on the outside that is not the same. So that means that this is uneven. It's a polar molecule.